Good afternoon. I'm here at Embedded World 2023, and once again, I'm delighted to be joined by Pelle Svensson, Product Marketing and Business Development for the Product Center Short Range at u-blox. And today, we are going to be talking about the new high-precision GNSS development tools from u-blox. But before we get started, would you just like to give us a brief introduction to yourself?
Yeah, I'm a part of the product strategy group in Product Center Short Range, as you told us, working with Bluetooth and Wi-Fi connectivity. I'm part of the strategy team and looking at the product marketing specifically.
Fantastic. And tell us a little bit about u-blox as well as a company.
u-blox is a more than 25 years old company founded around GPS, satellite-based navigation system. We are a leader in positioning system based on satellites, developing on silicon and modules. In addition to that, we do also cellular connectivity, where we develop our own silicon as well as modules and software on top of that, of course.
Yeah.
In Product Center Short Range, as I described, we are dealing with Bluetooth and Wi-Fi, making modules on various suppliers' chipsets. We are active and successful in automotive and industrial applications.
Excellent. Thank you very much. So before we talk about the new development tools from u-blox, can you tell us a little bit more about high precision positioning and how it can be achieved?
Yeah. This is based on GNSS, what we call Global Navigation Satellite System. The first system that was on board was GPS, but now there are multiple constellations like GLONASS, Beidou, and Galileo. If you take a standard GNSS receiver and get the signal from the satellite, it normally has an accuracy of a few meters. There are errors coming from the clock time in the satellite, from the orbit, and from the atmosphere. But if you put another satellite receiver next or a few meters away from the first one, they will have the same error. So the relative difference is on centimeter level.
Okay, and what would you say then are the key benefits of this technology?
Yeah. So if you install one receiver with a known location, it can calculate the error and send that to the second receiver. And what we do in u-blox is that we have a service called Point Perfect GNSS Augmentation Service, where we have a continent-wide network of base stations where we measure and collect those errors. And that is then fed into the GNSS receiver of the mobile device, moving device, delivered from our ThinkStream IoT platform, and can deliver via satellite communication or via IP network through cellular or Wi-Fi. So we use the Spartan message format, and we deliver that over MQTT, a protocol for cost efficiency. So that is how we can achieve. We send correction data basically over the full continent. So any moving device using our receiver and our Point Perfect service will be able to achieve 2 to 3 centimeter level precision, what we call high precision.
Fantastic. And the demand for this sort of scalable high precision technology is growing rapidly. So why is that?
Yeah, with the solution that we made for a mass market, there are a couple of new interesting applications that can use HPG, high precision GNSS. Example is robotic lawnmowers. Traditional robotic lawnmowers, there is a wire indicating the boundaries of the garden, and the lawnmower moves until it reaches that and make a random turn. So in order to cover the whole garden, it has to randomly run around and spend potentially also mow the lawn multiple times in the same spot. Takes more time, takes more energy. So with high precision for such a solution, you can get that to move accurately and with precise and spend less time and less energy.
And following on from that point then, which markets are seeing the most demand for this technology?
As I said, slow-moving robots like lawnmowers, but also delivery robots, where we see some uses in some cities. E-bikes, specifically then shared micromobility, where there are operators putting e-bikes into a city and subscribers can use them. But cities are now putting restrictions and some requirement on the operators. They cannot drive full speed on the walkway. They can run higher speed on the street.
Yeah.
They have to be parked in a specific dedicated zones and areas. And with high precision GNSS, the scooter will know where it is and they can then adjust accordingly. Another example is agriculture. If you're driving a tractor for a full day, it's fairly complicated to drive straight all the time.
Yeah.
You're covering same areas with multiple small arrows. You're spending more time and more fuel and more fertilizer than you need. So with high precision here, you also spend less time and save on energy and resources.
And I understand the existing high precision solutions have been unable to meet the demands of these markets. Why is that?
And mainly due to the complexity, the size, power, and specifically the cost.
Okay.
The solution that we bring to market is made for mass market. It's affordable for these kind of use cases.
Fantastic. And tell us a bit more then how u-blox is delivering the next level of scalable high precision technology.
Yeah, this F9 platform that we have developed implements all the features, the algorithms, the protocols, and of course the service, the correction service, the point perfect to deliver this in an affordable fashion. So it can be used in those consumer type of applications as well.
Yeah. Okay, let's talk a little bit about the XPLR-HPG series. I understand you have 2 Explorer kits, one compact and one modular. So let's start with the XPLR-HPG1, which is a flexible platform for u-blox high precision GNSS solutions. So tell us more about that.
Yeah, it comes in a box like this, and inside the box there is a baseboard where we have a Wi-Fi module with an MCU capability, Wi-Fi Bluetooth combo module. And on that board, we have micro bus connectors coming from a company called Micro E. And they are making 1,200, 1,300 different clickboards, including our modules for GNSS communication via cellular as well as positioning or short range. So these clickboards goes onto this modular fashion, and you can then use that for evaluating, prototyping your high precision GNSS application. With this kit, which by the way is fully source code available as hardware on GitHub, we also have developed the u-blox, which is a software library of components that is used to communicate from the main MCU to the different modules, but also run the different application that we have developed as example code. So when customer buy this kit, they can download from GitHub and start prototyping right away.
Excellent. And what about the XPLR-HPG2, which is the compact platform? Tell us more about that kit.
Yeah, it includes basically the same components, but it's mounted on one board.
Okay.
So it's much less flexible, but on the other hand, much smaller, maybe simpler to use. It comes with the same components. There is a Wi-Fi, Bluetooth, wireless MCU, NINA, W1 on this one. There's also the GNSS receiver, ZF9R, which is also has dead reckoning built in. There is a cellular communication module called LoRa R6. And finally, there is a NEO D9S that is able to run or receive the correction data via satellite communication channel. There are also some SIM card holders. There is a SD card for storage and logging of the results, so you can afterwards look at it and monitor. And of course, the kit also includes all the antennas for LTE connectivity as well as GNSS receiving capabilities.
And following on from that then, what is it, do you think, that make your solutions stand out to similar ones?
Yeah, it's a one-stop shopping from u-blox. We have developed a board with every component necessary to evaluate and start doing prototyping and proof of concept with our open source components.
Yeah.
It has all the hardware that we create for creating centimeter level positioning. It has the augmentation service, the point perfect, plenty of open source code for different applications in what we call the u-blox on GitHub. and the whole design, software and hardware, is available as well as an open source.
And how does u-blox work with Digi-Key then, and what benefits does this partnership bring to the end user?
Yeah, they will soon have this HPG2 kit that comes out first. The other one kit comes a little bit later. But this is going to be available on Digi-Key, so every engineer has an interest in exploring, evaluating, and potentially prototyping around high-precision GNSS. They have everything available from Digi-Key.
Excellent. Well, thank you very much for your insights today. It's been a real pleasure speaking with you again, and hopefully see you at the show next year.
Okay, thank you.
Thank you.